All right, let's move on with example 2. Example 2 says, for any rhombus ABCD, decide whether the statement is always, sometimes, or never true. We're going to draw a sketch and explain our reasoning. Okay, so first of all, this is a rhombus. So we want to think about all the properties of a rhombus. So I'm going to go ahead and sketch over here rhombus ABCD. So when you're sketching a shape, or actually when you're naming the vertices, they go in order kind of around the circle. So pick one of the vertices to start with the first letter and just go in a circle. Okay, it doesn't zigzag across the shape because the name of the shape is describing the sides. Okay, so this is a rhombus. I know that a rhombus has 4 equal sides, so I'm going to mark that. Okay, let's decide, is this always, sometimes, or never true? Is the length of AB greater than the length of BC? Well, here's AB and here's BC. Well, no, that's never going to be true because these two sides are congruent since we're told it's a rhombus. So I'm just going to add never as my answer. And then my explanation is that a rhombus has 4 congruent sides. A rhombus has 4, and you can use the abbreviations if you want, congruent sides. You can write the words out if you'd like as well. Either way is fine. Okay, that's a sufficient explanation. All right, I'm going to use the same picture above. It says that the measure of angle A is equal to the measure of angle B. So here's A and here's B. Okay, well, if it's a rhombus that, well, let me back up. So a rhombus is a parallelogram. So in parallelograms, I know A and B are supplementary. But if A and B are equal, this rhombus is also a square. So this is going to be sometimes. So I'm going to start with the word sometimes. And so I need to explain what I just talked about. So let's see. I'm going to say if the rhombus is a square, I'm going to say here actually, if the rhombus has 4 congruent angles, comma, it's a square. I'm also going to say here, but not all rhombuses are squares. Not all rhombuses are squares. So you could say something like, you know, the rhombus is a parallelogram, therefore, you know, consecutive angles are supplementary. Okay, let's move on to example 3. All right, example 3 just says to classify the special quadrilateral, excuse me, explain your reasoning. So that's going to be the most time-consuming part of these examples, is explaining. Okay, so I like to think through and kind of talk about what they are, and then I summarize it in, like, you know, a few sentences. So here's what I see. Actually, I'm going to back up. I see a 4-sided shape. I'm going to go to page 1. All 3 of these say these are quadrilaterals with extra properties. So what I'm looking at is a quadrilateral. This is a quadrilateral, but it doesn't show me 4 right angles. It doesn't show me 4 equal sides. It doesn't show me it's a rhombus. Oh my goodness, I'm so sorry. It doesn't show me that it's both a rectangle and a rhombus, so I can't say it's a square. But what I do see are opposite sides are parallel, so I know it's a parallelogram. Now, if it's a parallelogram, I also know that opposite angles are congruent. So I can go like this. Now I see 4 right angles. Now I can say, yeah, this is also a rectangle. But can I move on and say it's a square? And I cannot because it doesn't have equal sides. Okay, so it is a rectangle. All right, so now I need to explain, I need to write down what I said. I have to first say, or I have to first state why it's a parallelogram. So I'm going to say it's a parallelogram because opposite sides are parallel. It's a parallelogram since opposite sides are parallel. Okay. Now, since it's a parallelogram, opposite angles are also congruent. Oh, hang on, I just realized I spelled this wrong. Let me fix this word over here. Since, I'm going to say are also opposite angles are congruent. I'm going to use the congruent symbol. So I have just, in these two sentences, talked about why it's a rectangle. I'm going to say here, not a square, since all sides are not congruent. Okay, so we need to say enough, to get our point across, but we have to cover all the details about it. So I can't just say, yeah, it's a rectangle. I see a couple of right angles. Like I have to step through that logic. Okay, number 2, or second one. All right, I want you to pause, and I would like you to try to come to a conclusion on what shape this is. Okay, I see a 4-sided shape, so I'm going to start most generic. It's a quadrilateral. I also see these expressions. So that tells me, since those are all the same, I can do this. So now I have gotten to a rhombus because it's a 4-sided shape with four equal sides. Can I get more specific? Is it also a rectangle? Is it also a square? So I see the 4 equal angles. Okay, so if these are the same and all 4 add to 360, can't I figure out what each one is? So if I do 360 divided by 4, these are all 90-degree angles. So I'm going to come in here just so I can use this visual for myself. I don't have to mark that. So now I have a rectangle. And so since I have both a rectangle and a rhombus, I have determined that this is a square. So if you want to write that word at the end, you can. And like I said a second ago, the process you go through, it might be different for everyone. So I have to explain all of that. So I'm going to say here that the quadrilateral has 4 congruent sides, so it's a rhombus. The quadrilateral, and I'm going to go ahead and abbreviate, quadrilateral has 4 congruent sides, so it's a rhombus. Let's say all 4 angles are 90 degrees since 360 divided by 4 equals 90. Therefore, it's a rectangle. Okay. And then I can say, since it's a rhombus and rectangle, it is a square. Since it's a rectangle and rhombus, it is a square. Okay, so in order to explain that, we have to go through all of those steps because I can't go straight from quadrilateral to square unless I know it's both a rectangle and rhombus. So I have to step through all that. Okay, let's do the same on the last one. I want you to pause, see what you can come up with, and then come back and we'll formalize it in a few sentences. Okay, I see a four-sided shape. It's a quadrilateral. I also see this. I see these marks. So that means these diagonals are bisecting each other. So that makes it a parallelogram. Then I see a perpendicular diagonal here. And when I go back and look at my properties, oops, I meant this. Diagonals are perpendicular, makes it a rhombus. All right. Now, if I can also show congruent diagonals or right angles, then it's also a rectangle. So let's see if we can go farther. I can't get to anything about the angles being 90. So the farthest I can get here is a rhombus. Okay, so I need to step through how I determined it was a parallelogram. I'm going to say here that the diagonals bisect each other. So it's a parallelogram. Diagonals are perpendicular. I'm going to use the perpendicular symbol. If you want to write the perpendicular symbol, you can. So it is a rhombus. Okay. And that's really as far as I can go. So that would probably be sufficient for our explanation. All right, so one more example here. We are gonna get back to some calculations. All right, number 4. I see here that I'm told it's a rhombus, so I'm thinking about rhombus properties on this problem. The diagonals of rhombus ABCD intersect at point E. Given that the measure of angle BAC is 53, so when I look for that, it's already labeled for me, BAC, so there's your 53. And then DE is 8. DE right here is 8. Find the indicated measure, I guess measures here. Okay, there are 6 that I'd like you to figure out. So we'll go ahead and pause the video. Try to get through all 6, or if you get stuck, come on back and I will go through the reasoning behind them. Okay, DAC. Actually, I'm going to go like this. I'm going to mark a couple things. I'm going to mark that for sure. I also know the diagonals are perpendicular. And that's about as much as I'll mark. I don't want to get too many symbols on here. Okay, DAC. So the measure of DAC, DAC. So I really want to find the measure of angle A here. So DAC, what do I know about this rhombus? So I see a 53-degree angle. So I'm going to come back here. In a rhombus, let's see, angles. The diagonals bisect vertices. So the diagonal is cutting that angle in half. So if the one on the right is 53, this one here, oops, let me get my pen back, is also 53. So actually, let me back up. I outlined DAB. Back up. Oh, I can't. Let's see, I might have to erase some of this stuff. Okay, DAC is this one. My bad, right there. Okay, so that means I don't have to worry about it. I was going to add 53 and 53 together. So the one right next to it is also 53. So I'm going to write 53 degrees for DAC. Okay, ADC. Oops. Just get rid of that. ADC. A down to D over to C. Okay, that's the whole thing right here. All right, I want all of angle D. So I'm going to write a couple things on my picture. This is 53. And so because this is a parallelogram, these two angles are supplementary. So let's do, if I take 53 and I add 53 to it, I get 106. So I want to take 180 and take away 106. And that will give me the angle I need. So 180 minus 106 is 74. So that one's 53 degrees. This one is 74 degrees. Okay, AE. Let me get rid of these circles. All right, AE. That's right. Let me switch colors here. All right, I need that. Okay, I have an 8 right here. So I also know that one over there is 8. That may or may not help me. I don't know anything about A over to C. Now, I do know, though, that this is a right angle, which makes this a right triangle. So I'm going to outline this one. So you've got this right triangle here. And so you have learned how to solve this. So if maybe I bring the right triangle over here. So this is 53. That side is 8. You need this length. Okay, you need A down to E. So I have one side length. I know the procedure. I can use SOHCAHTOA. So I've got from 53, this is my opposite leg. This is my adjacent leg. So if I am thinking about SOHCAHTOA, I am using tangent here. Okay, so I need to do the tangent of 53 degrees equals 8 over x. And then when I solve from here, I'm going to have x times tangent of 53 equals 8. And then now I'm going to divide by tangent of 53. Okay, so I've got 8 divided by tangent of 53 is like 6.028. We could round it to 6.0. Let's go ahead and round it to 6.0. We could do 6.03. I guess just however you round it, you'll just be consistent with that rounding going forward. Okay, AED. So A down to E over to D. All right, that's this angle right here. So it's in the middle of the diagonals. So it is, since the diagonals are perpendicular, that angle is also 90. Okay. All right, DB. D all the way over to B. So this section is 8, this section is 8. I'm going to add them together. And so I get 16. And then AC, A down to C. Okay, well, I determined this one was about 6.0. So however you rounded this one, I'm just going to double it to get here. So based on what I wrote, I'm going to do 12.0. Now, if you used 6.03, then you would have 12.06 for AC. So as long as they're connected, then you're good. Okay, that wraps up this section on rectangle, rhombus, square.